Hi friends, here we are given two circles, both of radii 1. Right. What does that mean? Intersect such that the circumference of each one passes through the center of the other. Right. So B and C are the centers of these two circles. And obviously BC is the area of both the circles, which is equal to 1. Right. The circumference is passing through the center. So BC is equal to 1. And because the intersections are on both the circles. This point is on on this left side circle also, and this point is on the right circle also. So this point is equidistant, or this point is actually radius of this circle from the center, which is 1. Okay, and this point is actually radius of this circle also, which is also 1. Obviously, what that means, this triangle is actually an equilateral triangle. Right, ABC is an equilateral triangle. What is the area of the intersecting region? We want to find what is the area of this region, this entire region, this entire region. Now, how to find the area of this region? Area of this region is very easy. First, if you see this region has got one sector, has got a sector, and has got triangle. So we have to find the area of the sector minus area of this triangle. Area of this triangle ABD, this triangle, and the sector of ABDC, this one, right? The sector area and the area of the triangle, right? Now, how do you find sector area? First, to find that, we need to find what is the angle of the sector. We just derive that this triangle is actually equilateral triangle. Obviously, this also is an equilateral triangle. So, angle in this sector is actually equal to 120 degrees. So, area of this sector is 120 degrees by 360 degrees into pi r square. R is any one. 120 by 360 into pi r square. So, which is one third of pi. Pi by 3 is the area of this sector. Now, what is the area of this entire triangle? Area of this triangle is, earlier we discussed area of a triangle. Area of a triangle is half AB sin C or BC sin A, half BC sin A. In this video, we have discussed area of a triangle is half BC sin A or AB sin C or AC sin A. Basically, what are two sides and the including angle? Sine of the including angle on these two sides, half of that. Right. Now, this angle is 120 degrees and this side is 1, this side is 1. So, half into 1 into 1 into sine 120. We know sine 120 is root 3 by 2. Right. Sine 120 is root 3 by 2. So, half into root 3 by 2, which is equal to root 3 by 4. Well, that is this. So, area of this part is this part. This part is root 3 by 4. And area of this entire part, this this small circular part plus this triangle. This triangle is 5 by 3. So what is the area that you want? 5 by 3 minus root 3 by 4. Right. That gives us one part of this, the entire black region. Right. We want two parts of this black region. Right. So 2 into 5 by 3 minus root 3 by 4. That is our overall area, which is equal to 2 pi by 3 minus root 3 by 2. Right, guys. It's such a nice problem. Only thing we should note is area of sector area, and triangle area. We just need to calculate these two areas and recognize that this is an equilateral triangle and the angle is 120 degrees here. Thank you, guys.